Hello, everybody. Thank you for coming. Happy Thursday. Glad to have you here. Today's going to be mostly a work day to work on some recursion problems. Run into, I don't know how to do this, and ask questions and figure it out as a group. So some announcements. The announcement I have is there is a math talk that's happening next Wednesday in Galileo 202, and I am giving the talk. It's about something called formal concept analysis, which is a computing technique that's based in theory, so that's why it's like a math talk, but it's also a computer science talk. And so it's going to be really interactive. We're going to build this structure based on your like the things that you suggest. So it should be really fun. If you're interested, come by. It's also useful. It's also like a useful technique for data science, because it's used to like organize your data set. So if you're in data science, I recommend that you come to this as well. Okay, so just to review, last time we talked about recursion. We talked about what is recursion. It's a method that makes a call to itself. And the key thing there is that it makes a call to itself in a simpler instance. And so we looked at some examples. We talked about factorial and how factorial is a naturally recursive problem because when we are calculating the factorial of some number n, that's just n times n minus 1 factorial. It's naturally recursive because as you break it down, you're doing the same thing over and over again. So just call it recursively. We talked briefly about how if you've seen proof by induction, how recursion is kind of similar to that, where we have a base case and then we have the recursive case. Proof by induction kind of has more steps where you have the inductive hypothesis and the inductive step. But for recursion, we just have the base case and the recursive case. We talked about the rules of recursion. The number one rule, have a base case. You must have the simplest possible thing you can do in order to solve this problem. You also have to make progress. That makes sure that your program isn't just running forever and ever or you've got to make progress. So you have to find a way to simplify the problem a little bit at each step. Number 3 is once you have to put in a lot of thought to get a recursive program to work well. And then once you do that, you assume that it works. So put the work in first, draw it out, figure out what's going on, and then you got to believe. And then number 4, which we saw in Fibonacci, is that you should not duplicate work by solving the same instance of a problem in different calls. So we saw here over in Fibonacci, where we calculate for fib of 5, we calculate fib of 3 twice. And so that's not ideal. For fib of 5, that doesn't make that much of a difference. But when we tested it for like fib of 50, and it took a while to run. And so part of the assignment today is making sure, is fixing that. So part of the lab is you're going to do some memoization, and we'll walk you through it to make sure that you can get that done. Okay, let's go back. Okay, so we talked about rule number 4. Then we looked at some examples. Let me pull those up. So we came up with a recursive implementation for the sum of numbers from 1 up till n. That's fairly straightforward. We also did factorial, where in each of these we have a base case, and then we return the recursive case. And the way that that works is, so for factorial, each of the recursive calls is stored in a call stack. And that's how the compiler processes your program. And so this is something that I recommend that you do when you're testing out recursive methods and trying to plan out what's happening, is draw out the call stack. So what gets added to it, when does it get popped off? So when does the method finish? And then what gets returned after each step. So if you draw that out, you'll be in a much better position rather than just sitting there staring at the code like, what's the word? Just like trying and failing. If you get to that point, take a minute, pull out a piece of paper, draw it out, and try and figure out what are you actually trying to do. The other thing we did was we looked at two different recursive methods, print descending, where we print the numbers from n all the way down to 1. And then we had print ascending, which was printing 1 all the way up to n. And so the difference between these two methods is A, the name, and B, the order in which we have the recursive call and the print. And so this shows that the order in which you make these calls, the order in which your method has its statements can really matter. And so a lot of attention needs to be paid when you are writing a recursive function. Next thing we looked at was Fibonacci, which is the Fibonacci sequence is 1, 1, 2, 3, 5, 8, 13, 21, and so on. Where we start with 1 and 1, that's our base case. And then we calculate the next number in the sequence by adding the two previous numbers. And so for a recursive implementation, we've got fib of n minus 1 plus fib of n minus 2. But then there's the problem with the compound interest, where we don't want to do this because we're repeating work. And so, yeah. So we'll fix that with memoization. Talked about like an example. We also talked about how that call stack, the stack of activation records, that's one technique you can use to kind of draw it out to yourself of what's actually being called. When am I doing this work? Talked about other recursion examples. Talked about common errors, and we're not doing that one. Okay. Any questions on recursion? Anything you were super confused on last time? Because recursion is confusing. All right. So let's look at my plan. Okay. So someone asked me to give a demo of like so you clone the labs from GitHub usually, and someone asked a question of how do you do this? How do I set this all up? Do you have a question back there?
Yeah, are cloning and forking the same thing?
Cloning and forking are not the same thing. So, okay. So I'll preface this by saying that I'm not an expert at GitHub. I've learned just enough to be able to do the things that I need to do. So there's a chance if you know GitHub better than me, feel free to correct me. So when you are in a repository, go lab 07, let's go. So you can clone it. If I copy this link, let's say I'm on the command line somewhere. what do I want to go to? Documents. I can say git clone, and then I can put the link. And so what that's doing is, this is what you do when you are cloning it from VS Code. It's the same process. It just looks a little different because it's on the command line. And so that's taking the code and making a local copy. To fork it, if you were to fork a repository, this is creating a copy that then you can edit the code and do something, but that's maintained on GitHub. So if you wanted to like fork my lab 7 repo and then you wanted to update it for do this problem instead, here's new instructions, add something, then you would fork it and make those changes. But for the labs, since you just want to download and do it, then cloning is the way to go. Okay, so what I want to do is I want to show you how I make a repository, and I'll show you kind of 2 different ways. So let's see, what have I got open? Okay, so I haven't uploaded lab 8 yet because I'm figuring I'm going to walk you through it and then you'll see how it works. So I've got this README that is lab 8. And so I'm going to not create a new fork. Let's just go here and how do I do this? There we go. New. My repository name, lab 08. There's a difference between public and private repositories. So all the labs that you have cloned are public because you can access them without me saying I only want these people to access. When I'm working on like research projects and things that I don't want anybody to see the code until we're all done, I'll tend to make those repositories private for privacy reasons. And so like people don't steal the work or something like that. So that's something to keep in mind if you've got something that, especially as you're working on the like homework or something, and if you don't want someone else to like go in and be like, oh, what did you do? Oh, I'm going to take that code. Consider making your repository private. Okay, so I don't want to add a README because I am going to upload mine. So that's it. I just create the repository. So now since I have the README file already written, I can just drag and drop it here. So let's open, where does this live? Redo, lab 8, actual. Okay. So let me select these and nope, I need to say upload an existing file. There we go. Okay. So now lab 8's published. These are all the instructions. I'm going to read through it just to make sure that it makes sense. Okay. The Gideon Gale signature did not, it doesn't show up in dark mode. If I turn it to normal light mode, scroll all the way down, there it is. So, and it's easy to use that. So let's also try, I want to show you what starting one of these looks like from VS Code. So if you like create a project in VS Code, let's say I'm in my slides folder where I want to make this available. So let's go to source control And then I would say initialize a repository because currently it's not published anywhere. So if I initialize repository, typically you'll also want a file called .gitignore, which is where you say, here's all the files that I don't want Git to look at, which is really necessary because on Mac, there's a file called dsstore, and you don't want to upload that. That's really just for like your own local computer. So I will write that file name in the gitignore, and then it disappears from the changes that are going to be pushed. So once I'm ready to commit everything, I have to stage all the changes. So I've made changes in this folder, and I have to say, which changes am I going to push to the cloud? And so I can choose like this one, and this one, or I can just stage everything. So that's what I'll do here. And so then, thank you, Google Drive. So then there's staging, there's committing, and there's pushing. And so staging is when you are like, these are all the changes that I want to go there. Committing is like, okay, this is the part that I'm unclear about. So if someone knows the difference.
What?
Committing and pushing. So pushing is actually like sending all the things. Yeah. Okay, so yeah, so it's like you're setting the stage and then pushing is when you actually upload everything. Okay, so at this point, when I'm ready to commit it, I can say, let's say commit, and then I want to publish branch. Oh no. Do we need to log in? Okay, and so in VS Code at this point, this is where I say, do I want to make it public or private? In this case, I'll make it private. So it uploaded, and then if I open that link, here it is, and it's private. So the thing is, when you have a private repository, then you want to add collaborators, you go to settings, collaborators, and then you can add people. So if you have their GitHub username, this is where you would type that in. No. It's a private repository. There are secrets in here.
No, we're gonna go over this in class, right?
I mean, maybe it's a little bit of spoilers. Anyway, okay, so that's creating a repository. Let's say I add a README here and I type some things here. So I've made some changes in the cloud, and I want to pull them so that into my local area so that I can work on it some more. On the command line, I would say, nope, I always forget. How do I pull up there we go. Control backtick. On the command line, I would say git pull. That works. Another way to do it is to go, that might also work. But pull. And so what pull does is it looks for what's in the cloud and then it brings it into your local area. So once I do that, then down here, I've got my README file. Okay. I think that should be it. Any questions?
The same thing for push. Like, if there's a script on like a Git repository that I'm working on,
Mhm.
I change it on my local network or whatever, and then I want it to go to the cloud and edit whatever's stored on Git.
Mhm.
Git push and it changes it.
Yeah. So I've made some local changes. And so then I go here. First, I have to stage the change. So I click the plus. If you forget about it, it'll warn you like, hey, you don't have any unstaged changes, or you don't have any staged changes. Do you want to stage everything? Put some commit message, then you commit, and then push. And then it's updated. So now if I go to the web and I reload the page, now the README is updated. So I encourage you to use this for homework, especially as you're sharing code. So hopefully this gives you a good background. Does anybody have other questions? Okay, there's also tons of tutorials on this online. So if you're ever confused, like it's everywhere. But Git is also a really useful tool that I encourage you to use, especially for collaboration. Okay, so now that lab 8 is up, so now if we click on lab 8, we'll get here. And so today is a little bit different. So we're going to be working in pairs again, random pairs. And today I'm not giving you any starter code. I would like you to create a project and then create individual classes for each problem and do what is asked. So one of the problems is Fibonacci number with memoization. And I pretty much walk you through that. If you've got questions, call me over. Then I've got a problem for you to calculate whether a number is prime or not. That one has, I want you to do it iteratively and recursively. So iteratively meaning you do it with like a for or a while loop, and recursively is the recursive method. The third one is palindromes. So in your main method, you should have all of these and check, is each one a palindrome? And then the fourth one might be a little bit tricky. We'll see how far it gets. But this is Pascal's triangle, where so the top number and the first and last number in each row is 1. But for the numbers in the middle, so for like this guy, you calculate that by adding the 2 diagonal numbers. So 1 plus 1 is 2. You get 3 by adding 1 plus 2. You get 6 by adding 3 plus 3. And so your job is to recursively compute Pascal's triangle. It doesn't have to, the spacing doesn't have to be exact. It can just be like a left aligned list, like list of numbers. That's fine. I don't care about the spacing. I just care that the numbers are correct. And then some text file about, tell me about recursion. What is it? Why would you use it? And I'll give you 5 points extra credit if you go along with my silly professional letter format. So yeah, so that's the assignment. I'll pause recording so that we can set up the list, and then the rest of the time is yours to work on. If you do finish the lab early, which I don't anticipate, but just in case, you can make a LeetCode account, and I've picked out some problems that you can try to work on. LeetCode is a platform that's used in coding interviews. So if that's something you're interested, this helps to prepare you for that. But you can work on these once you finish the lab, if you have time.